Hi, welcome to this video about Reducer. So Reducer is an SQL simplification tool which I programmed some time ago while I was working at Oracle. Oracle has been kind enough to open source this tool, and it's now part of the random query generator tree in Launchpad. If you know how to use Bazaar, you can get Bazaar by doing something like get Bazaar maybe, or BZR. And once you have installed Bazaar, you can enter a command like, for instance, if you want to put it in TMP, BZR branch, branch n, and that will pull in the random query generator code for you. Another name for the random query generator is rangen. Once you have that, you can go into here and you can check out the script in there. So here in the background you can see Reducer running. So it's simplifying a crash that I've been seeing. And it's going through various stages and through various trials, and we'll have a look more into that in a minute. What I wanted to show you is how it's working. So here you can see it tried something, but in this particular case I'm looking for a crash and it didn't produce a crash. Then I tried something else and that worked. So this is one of the later stages. So if we scroll up a little bit, you can see there's a stage 3 and a stage 2 before that and a stage 1 before that again. And in stage 1 is where the biggest chunks get reduced. So let's say, let me just get rid of this. So let's say that's the initial input file was 40,000 lines of SQL. Then what Reducer does is, first of all, it will split up any insert. So if you have something like insert and then you have A, B, and so on, it would have multiple insert actions on one particular line. It will split those up into this format so that it can more easily say, okay, I want to get rid of this line just to see if the issue will still reproduce if I do so. So you might get a translated file, if you will, ending up with, for instance, 120k lines or 100k lines. All depends on what was used originally to generate the insert, whether it has multiple inserts on one line all hooked together one after the other or whether it was already split up. Anyway, let's say it has 100k lines, then stage 1 will go and say, okay, if I drop for instance line 30,000 through to 60,000, will the issue still reproduce? If it does, yes, great, it will continue on a higher on the same number of lines. If it doesn't, then it will try and reduce the block, so it might say, okay, this time I want to do 20,000 till 30,000, and so on and so on and so on. It always makes the blocks larger or smaller depending on how successful it is. So here you can see how that works. So here there's no crash, and so subsequently it's reducing the chunk size down from 5 to 4. Then at some point, so then it has a crash, so it increases it again, has another crash, increases it again, doesn't have a crash, brings it back down, and so on. And you might say, why doesn't it bring back down to 5 here? It's because the file is getting smaller and it's based on a percentage. So in the beginning we're dealing with much larger chunks, and so a percentage of course makes more sense. So straight away here, the first crash after a few trials you know, a huge block of, you know, 8,385 lines was straight away thrown out. So in this case, there were 10,000 lines in the input file, and the restructured input file based on the changing of the inserts was 25,000 lines. So we started at around 2041, and you can see here it being executed. 2041, and let's see how long it took to reduce this file. So here we're now at 2124, so a good 40-45 minutes later, and we're down to 809 bytes, or 20 lines. And after stage 4, there's a few more stages that it will go through. It will go relatively quickly, and then it will be finished. So all in all, an hour for about 25,000 lines, which I personally think is a lot better, or very good at least, compared with some other tools. The big advantage of this tool is that it eliminates large chunks very early on in the process. There's another great set of features that it has. It does multi-threaded verification and also multi-threaded simplification. So originally when it started 10 different threads all running the same SQL code. You can see here how it's starting these various threads, and then it will wait for them to finish. It came back and it said, okay, they're all finished, and then it figured out, okay, all the threads reproduce the issue, so it's not sporadic. If it was sporadic, you would see something like only 6 out of 10 threads reproduce the issue. The issue is sporadic, and then the simplification will be multi-threaded as well. So not in this way, but multi-threaded as well. And it takes a different approach. So here in this case, it just goes, starts one MySQL, runs the code through it, checks if it crashes. While if the issue was sporadic, what it will do, it will go through the SQL file with 10 different MySQL Ds, and as soon as one of them crashes, that means that a shorter SQL file was found. So each time it will optimize the SQL file differently, so based on this sort of chunking, because you have now 10 reducers running, all using a random section from the file that they're trying to eliminate. And so if even one of them finds a better one, then straight away all the threads will stop, grab that better one, and then start going on that one with another random section. So this way you can even reduce multi-threaded sporadic files in a multi-threaded fashion. Okay, so one other important thing is here the run mode. So in this case it's running in crash testing mode, and it will look for any MySQL D crash. So let's have a look at how to set it up. But actually before we do so, let's scroll down. It's finished in the meantime, and here we see stage 4, stage 5. Stage 5 in this case is only very short, and stage 5 is trying to rename the table. So it's even trying to optimize each individual code. Stage 6 was really difficult to program, but very happy with the result. What it does is it actually eliminates certain columns from the table definition. That in itself is easy, but it also eliminates that in the rest of the SQL file. And that's reasonably successful. You can see here there's a number of crashes, and so each time there are columns being eliminated from the table and from the SQL, so that the resulting test case is yet much smaller again. So in stage 7 it's doing some final cleanup, a few more crashes, by the way, this message skipping the trial as it does not reduce the file size. So what it does is it has the original file, so that's the crashing file, I mean, which crashed, for instance, the last trial, and then it will try a variation. For instance, it will say swap something like this. For instance, it will say remove not null, and then it will test again and see if it crashes, and if it crashes, then we go make this our original file and loop through the process over and over with different changes. Now, excuse me. What happens is, in this particular case, it has tried this set, and that has checked the original and the to be tested SQL file for size. And if the size was smaller, then it will proceed. Yeah, if the size was smaller, then it will proceed. If the size was larger or equal, then it will not proceed, because of course that doesn't make any sense. So here it's gone to the process, and it's come up with 514 bytes, 11 lines. So so let's have a look at final output file, and there you have it. That's the final output file for this particular issue. So compared with the input file, which is 10 or restructured 25,000 lines long, you can see it's a huge difference as to what it has done. Okay, so let's see how to set it up. In this case, my reducer here is Reducer 6, but you can simply get it in that wrench and download, RKG download. So here's the program. So the only options that have to be set are these. And most of the time, the only one that you have to change is the base directory and the mode, and possibly the workday location. So let's talk about the mode first. So there are these modes, and Reducer is even able to do multi-threaded simplification based in combination with RKG, but this is still an alpha stage, and it needs more work. So we're not going to discuss 6 to 9. The most likely one you'll use is mode 4, which is crash testing. And in this particular mode, Reducer will look for any crash. Alternatively, you could use MySQL error output log testing. So in this particular case, you would need to set text as well, and here there's just an example of looking for the string strcmp in the MySQL error log. And this would be very handy for crash testing as well. So let's say, for instance, you're working on reducing an issue that says protocol end statement somewhere in the error log. So you could take this protocol end statement and insert it into the text string here. This text string accepts regex syntax, so you could have something like dot dot, where dot stands for any character or anything like that, right? A lowercase or an uppercase L in this position, and all that would work. So you can use that if necessary. So in that case you would set it to mode 3, you would set the text and it would be looking for that particular text, which is kind of handy if you have quite buggy code and you have 2 or 3 different crashes and you want to just reduce for one particular crash, not just for any crash. Then you can set it to mode 3 and look for a specific text. This text is ignored if you put it in mode 4, because then it will just be looking for any crash. Okay, mode 2 is MySQL CLI output testing, also very handy. So this could be used for testing of certain results. Now you can see here an example of CLI output. So the way this would have looked if I were to look at a browser, client. So here you have an example like this. So you did something like select C1, C2 from, and so on. And this was part of the output, right? And you might have had some more output. And this is the particular one that you think is faulty, and so you want to reduce the test case for this particular bit of output. So what you would do is from the command line client, you would just copy this text and paste it straight into here. The only thing you have to do is add prefix backslashes, because otherwise it would not interpret those pipes correctly. And you can see it works for character as well as any sort of output. You could even look for specific error messages that the client gives and that you want to optimize for, so that you want to get a test case for. So if your output was something like error 1003 got 30 got error -1 from storage engine. We've all seen those sooner or later. Then you could just integrally copy this text and paste it right here into text, and it would be looking for that in the client output. It just uses the Reducer uses the standard MySQL client, so any output you see in the MySQL client can be integrated here. Mode 1, Valgrind output testing. So in that particular case you would also set the text for a particular piece of information you have seen in the Valgrind error log, which is of course part of the MySQL D error log. So it could be something like 0x. You probably don't want to grab a memory address because those are most of the time very variable, but you could have something like a function name, right? To come back to that protocol in statement 1, if you saw that in the Valgrind output, then you might as well use this. Sometimes what I try and do is, like, if you see interesting characters, like in this case the colon is not very interesting, and that would just work fine, but I just grab a smaller piece of text. The smaller piece of text you grab that normally does not appear in the error log, so in this case protocol might be a better choice. You can insert here and ensure that you don't miss out on seeing something just because some mistake was entered or some special character was present. Okay, so that's as far as the mode goes. Now the other options are explained here in detail, but like I mentioned, the other one that you want to set is the base directory and also the workday location. So there's a few options here, 0, 1, 2, 3. One is the default and the one that you probably always want to use. It's basically using TMPFS, and that's, as you know, in memory, sort of, and it's quite fast. It's very beneficial because as Reducer is running through things, it needs to do it as quick as possible. Sometimes issues are not reproducible because the MySQL client, for instance, let's say you're running something else on your system and the MySQL client is executing queries, and it's not as quick as the original RPG run, or as whatever system you got your SQL trace from, then it might not be reproducible. So you want to work as fast as possible. Another good alternative is to set up a RAMFS drive, and you got the command right there for a 4 gig RAMFS drive. You can make that a bit smaller, but not too small. 3.5 I think is what it tests for. And you can tweak the code a bit if you have to, but I would just set up a 4 gig RAMFS drive and then just run it on that. You can also use an SSD, so I usually mount my SSDs as /SSD, hard-coded, I know, really bad, but you can also modify the code a bit and just change SSD to whatever part your SSD is if you need to. Or use TMP, but with the warning that it's disk bound, and so you're likely going to miss out on reproducibility, at least in some cases. There's more info there, so you can read through. The script is quite long. Just out of interest, it might be interesting to see some of the things that I was saying before as to how it reduces. So this is here we are in stage 3, and you can see some of the things it's trying. So it will try and reduce pretty much everything one after the other. It comes up with really small test cases because it tries and reduces everything bit by bit. So let's have a look at stage 6. That's an interesting one as well. So here in stage 6 it's trying to reduce the columns, and even though the resulting code now looks quite simple, this was one of the hardest things to code and to get right. Okay. So once you've set all those options in the script, then you would simply execute something like Reducer, and you would point it to the SQL file. And once you do that, it would start running. I won't re-execute this again because that might override my previous work, but you can see how it works. So you start it and it goes through. If there's anything that Reducer finds that are not the way it should be, then it will report so. It does quite thorough checking, and you can simply take care of it. So in this case, TMPFS didn't have enough free space, which I then cleaned up and then it worked. But the first few times you run it, you'll have to do a little bit of tweaking to your system to make sure that all the settings are optimal before you get started. Okay, so that's Reducer. It's very powerful. It reduces test cases quickly from very large to very small. You can use it with pretty much any SQL trace you have. If you do have a general query log type log, so I'll show you what that looks like. So in RQG, or sorry, specifically not RQG, if you run MySQL with where is the option? Okay, so if you run MySQL, the reason why it says MySQL here is that simply the way that RQG likes its options passed, because it passes them on to MTR, which is the MySQL test run tool. So here, just consider this option as being, an option that could be passed to MySQL or put into the MySQL section of my.cnf. So here it has the log output file, it has the general log turned on, and somewhere it will say where it has to log it to. So in this particular case, what happens is this generates the general query log or the general log, and that results in something that looks like this. So that almost looks like SQL, but the problem is that it has, all the extra information in front of it. The time, the query, and so on. So the time, the ID, the command, and then finally the argument. So there is a tool for this, and this tool you can get again using Bazaar by doing Bazaar branch Percouna-QA. And in Percouna QA there is a tool that's called parse general log, and you can say input file 6.sql, output file, so -I and -O for input and output options. 6C will do this time. And this parses this particular SQL file into something that's actually a proper SQL file. And now you can see it's nicely cleaned up and there's no more other information there. So that's an extra handy tool if you have to convert a log before using Reducer from the general log to Reducer. The log's written with MySQL dump, and you can go and look at the MySQL dump options to run it. They can be used pretty much exactly as they are because they're formed very well and cleanly. Sometimes what's really nice is you can grab a crashing query from either a GDB core editing, or you can grab the crashing statement just from the MySQL D error log, and then you can use that crashing query and insert it at the end of the MySQL dump SQL file. And the reason why we do that is, let's say that you have a crashed server, you can see the crashing query in the log, and you have a dump of your server. What is a good thing to try is you take the dump of the server, you take the crashing query from the log, and then you would insert the crashing query at the end of the dump. In fact, you would do it probably twice or 3 times, because some issues only reproduce when they're executed twice. So insert that query a few times at the end of the MySQL dump output, and run it to Reducer, or simply just run it once at the command line if you want to just verify if it's reproducible. But even that is not necessarily a good idea, because the issue might be sporadic, and so it might not reproduce the first time. So grab the total code and run it through Reducer, and let it do a job, and see what it comes up with. There's one more important item which I did forget to tell you about, and that's the MyExtra. So the MyExtra has to match the MySQL D settings of your setup, whether that's like a customer's environment, or whether that's the options used in a particular RKG run for testing. So if it was an RKG run, to give you an example, here in this case you can see there's lots of MySQL D options that were used, and it's a bit hard to parse that. Again, in Percouna QA there's a file that's called prepare reducer, and I'm going to be very hacky here, and because this script is a work in progress, but there is a very handy command in here, this one, that you can use and execute against that CMD file. You just have to change it a bit, copy and paste it out, change it a little bit, put it back on one line, and run it against this particular CMD file, and it will nicely get out all those MySQL D options, so you don't just have to copy and paste them manually. The idea is, either from your my.cnf if it's customer's environment, or from the CMD file if it was RKG run or from the trial x.log if you don't use the Percouna QA tools to create a CMD file. Either of those, you need to get your MySQL options out and integrate them into the MyExtra. Just a little warning with that. The way that the options are specified here is not in an MTR fashion, because Reducer does not use MTR, it does all its starting and stopping and server status checking by itself. So you don't want to have the -- MySQL in here. Not the -- MySQL equals and then some other option, and then again MySQL and then again some other option. So what you want to have is not this, but instead this. So basically what you would find in any standard my.cnf file. And again, that's where that little piece of code comes in very handy. Where is it? Here. It comes in very handy because it also removes that MySQL strings straight away from the command file. Okay, so that's it. Using it for any given situation, if you have an SQL file. So once you have the SQL file, you know, if need be, use the parse script in Percouna QA to put it to make it straight SQL, or if it's already straight SQL, you can just use it, and then set reducer options. So you want to remember MyExtra, you want to remember the mode, the location of MySQL and where your working directory will be, and then basically start it. Reducer.sh and some SQL file. Okay, that's it. Have a play around with it and let me know if you think it's any good.